Hello friends, welcome to Basic Electrical YouTube channel. So in this lecture, I am going to explain measurement of three-phase power by using two wattmeters for delta connected load. So in the last lecture of three-phase AC circuits under module 2, you go to the playlist under module 2. The last topic on three-phase circuit was measurement of three-phase power by 2 wattmeter method for star connected load I was explained. Now in this lecture, same topic, we can also measure three-phase power by 2 wattmeters for delta connected load also. Okay, so it is very important. So in exam, they can ask either star connected load or delta connected load. Got it? So till now, for old scheme syllabus, they didn't specify. They asked this question many times. Almost 4 to 5 times they asked that question. But not in a single time they didn't specify you have to write for star only or delta only. Okay. They didn't specify the type of connection. Under that condition, you can explain either star connected load or delta connected load. Which feels easier for you, you can write that connection. Okay, got it? But 2 wattmeter method, we can measure power for both the three-phase delta connected load or star connected load. Okay guys, look at the question, how the question will become under this topic. Show that 2 wattmeters are sufficient to measure three-phase power for delta connected load. Okay, so let me draw the diagram, neat diagram, delta connected load. See, this is, please observe how I am going to write. This is a wattmeter. Wattmeter will have two coils. One is called current coil and another one is potential coil. One is current coil, other will be the potential coil. So this is R phase winding. Starting end is R1, finishing end is R2. Okay, like that you consider. Similarly, this is another phase winding. So let me write, and this is another phase winding. So I connected all these windings in delta. So this is Y phase winding, starting end is Y1, finishing end is Y2, and this is Y phase. Okay, I will write Y phase here. Similarly, B phase starting end is B1, finishing end is B2. Okay, so now I have taken R phase supply terminal here. So the current coil terminals are M and L, and this is connected to B phase, and in Y phase I am connecting another current coil to the Y phase. Okay, this is Y phase, current coil of wattmeter 2. Okay, so CC means current coil. Okay, now in wattmeter we have another coil, that is potential coil. So the potential coil we need to connect between any two terminals. So this what I am writing now, that is potential coil. So I am connected the potential coil. So potential coil terminals are C and V. So P dot C, potential coil. Same coil I am writing for another wattmeter. Okay, so this is common point and this is voltage point. So potential coil. See, I connected 2 wattmeters in R and Y line. You can connect any lines, that is also valid. But phasor diagram slightly varies. However, the final answer remains same. In some colleges, they might have connect wattmeters in R line and B line. Some colleges will connect R and Y. It depends on it depends on teachers how they are going to explain. Okay. In the end, result will be the same. Okay, got it? So I connected 2 wattmeters in R and Y line. So now I am making some dotted lines to represent. This is W1. See, this entire part is wattmeter 1. Okay, similarly, and this one, this entire part, this blue color what I am writing, that entire thing is wattmeter 2. See now, what is current flowing in R line? IR current. What is current flowing in Y line? IY current. Look at here. Whenever this entire load is connected to supply, so this will going to receive current. This entire thing becomes load. Load receives current from the source. So IY current flows in this. Okay. Finally, it will come and connected here. Okay. Then similarly, B phase winding carries current IB. IB current flows till here. So let me write the nodes. This is node 1, okay, node 2 and node 3. Okay, got it. Now write the phase currents. These are line currents. IR, IY and IB all are line currents. Now write phase current. So by writing phase current, see the R phase winding. One end is connected to R line and another end is connected to where it is connected to another end is connected to where? Y. So therefore, the current flowing in this phase is IRY current. IRY is phase current. Then similarly, see the Y phase winding. Where Y1 is connected? Y1 is connected to where? Y terminal. Okay. Then Y2. Where is Y2 connected? Y2 connected to B terminal. So therefore, what current it carries? Very good. IYB. IYB. So current flows from Y to B. Similarly, what is the current flowing in B phase winding? What current flows in B phase winding? See, look at here. B1 is connected to B phase. Okay. And B2 is connected to R phase. What current flows in B phase winding? Very good. IBR current. Okay. IBR current flows in the B phase winding. So now, before going for derivation, okay, we know that first you write the notations of line and phase quantities. So what are the concept in delta? Line voltage and phase voltage both are equal. Okay. So what are the line voltages? Voltage measured between any two lines, VRY, VYB, VBR, like that. Okay. So between any two terminals, VYB, VBR, VRB, so like that, and VRY. So like these are the line voltages. Voltage measured between any two lines is called line voltage, and also same as phase voltage for delta system. Then currents, IR current, IY current and IB current. What are all this current? Very good. Line current. Okay, line current. And what about phase currents? IRY, IYB and IBR. IBR. These are all what? Phase currents. Current in each phase winding. Okay, got it? So if you want to copy, pause the video and then copy down. Okay. While explaining, don't copy the video. Okay, you are going to lose the connectivity, understanding the concept. Okay. See now apply KCL at node 1, node 2 and node 3. Okay. So now I am writing KCL at node 1. What KCL states? Entering currents is equal to outgoing current. See, at node 1, what current is entering? IR current is entering. Okay, plus another current, IBR current is entering, is equal to what is outgoing current? IRY. See, this current is outgoing, IRY current is outgoing. Now you write equation for IR itself. So from this, IR can be written as IRY minus IBR. This is current in R phase winding. Okay, current in, line current in R. Okay, R terminal. IR is IRY minus IBR. In the same way, apply KCL at node 2. Apply KCL at node 2. Okay, apply KCL this node. What is the current entering? IY current is entering plus IRY current is entering is equal to which current is outgoing? IYB. IYB. Now from this you write equation for line current. IY current can be written as IYB minus IRY. So these currents are required for me, okay, while solving while writing phasor diagram. That's why I am writing this. Next is apply KCL. Apply KCL at node 3. So apply KCL at this node. What is the current entering? IB current is entering plus IYB current is entering to node 3. So IYB current is entering. What is the current outgoing from node 3? Very good. IBR current. IBR current is outgoing. Now write equation for IB. IB can be written as IBR minus IYB. IBR minus IYB. Okay, got it? So this is the equation for IB current. See, IR, IY, IB line currents, and these two are what? Phase currents. So now, before going for derivation, we need to know this basic concepts. What wattmeter will do? It's going to measure power. So what is power formula? V I cos pi. Voltage into current into power factor. See now, wattmeter 1 reading. Wattmeter 1. So V means potential coil. I means current coil. See, in wattmeter 1, where is the potential coil connected? Between which terminals? See, wattmeter 1, W1, potential coil connected. One end is connected to R terminal and another end is connected to Y terminal. See, this potential coil connected between R and B. Okay, therefore, we can write VRB. Okay, got it? Similarly, current. So, wattmeter 1, current coil carries the current. Which current it is carrying? IR current. So, IR. Now, pi is nothing but angle between voltage and current. So, this angle we can represent in this way. IR at an angle of VRB. IR at an angle of VRB. So, this will be your wattmeter reading, first equation. Okay. So, now W2 can be written in the same manner. Voltage into current into cos. Okay, something you will get that we can look at later. Angle between voltage and current is this bracket. See now, see the W2. Where potential coil is connected, see V means potential coil. Where potential coil of W2 connected to Y and another is connected to B. So what I can write this coil? VYB. So VYB into what is the current carried by the W2? Which current carries in the W2 current coil? What is that current? Excellent, very good. IY current. IY current. Now, cos angle between these two quantities. That is IY at an angle of VYB. So, take that equation number 2. So, before proceeding to phasor diagram, so you write these equations in terms of line quantities. What is VRB? What is VRB? VBR or VRB? What is that? I am measuring voltage between any 2 points. What is that voltage? Line voltage. So line voltage. And what is IR? What is IR? IR, IY, IB. What are that? Line current. So we can also write VL, IL into cos. See, this one you don't modify with line parameters. Write as it is. Because we need to find what will be the angle between these two quantities. That is our goal, to find the angle between those two quantities. Okay. So take this equation number 3. Next, similarly, W2 can realize what is VYB? Line voltage, measure between any 2 points. 2 points are there, line voltage. IY is line current into cos. This one you write as it is. Okay, take that equation number 4. Now very important is we need to find what is the angle between those two quantities, IR at an angle of VRB. That is very much important. Okay, look at here guys. See, whenever delta is there, you write always reference as phase currents. Okay, so let me draw all the currents in each phase. So R phase current, IRY current. So this is current in R phase. Okay, IRY current. Next, current in Y phase. See, the understanding this phasor diagram is very important. So what is this current? IYB current, current in Y phase. And next is current in B phase. Current in B phase is IBR. See, you should write the currents in such a way that all these currents are displaced by 120 degree with respect to each other. So this angle 120, 120, 120. Like that you write. Now you take what currents you require, line current, IR and IY. Now IR. What is the equation for IR? What is the equation for IR? IRY minus IBR. See, whatever I wrote here, all these are original phasors. All these values are having positive values. If I need minus IYB means you just reverse that vector. If I need minus IBR, reverse that vector. If I need minus IRY, reverse that vector. Exactly opposite and of same length. How much length is there? In the same length you reverse it. Then it becomes minus minus IRY. Like that for everything. But I need what? IRY minus IBR. IRY is positive, so you retain that itself. Then what I required? I required minus IBR. Okay. So I am reversing this vector exactly opposite. So I am reversing that vector. So after reversing, this becomes minus IBR. Minus IBR. Okay. Very important. See, you must reverse in such a way that exactly opposite, and how much length is there? Same length you reverse it. Okay. Now join these 2 points. From this point, draw a line parallel to this vector and of same length. And from this point, draw a line parallel to this vector. See, at some point, both will meet. At some point, both will meet. What is that? That one is line current. See. Okay, look at here. This one is what? IR. What is IR? IR is what? Line currents. So guys, IR is nothing but line current. Be careful. Please give priority for understanding this. See now, look at here. See, from here to here, angle is how much? 120. If I reverse this vector, this becomes 60, this becomes 60. Now in that, line current divides. So therefore, this becomes 30 degree and this becomes 30 degree. So from here to here 30 degree and from here to here 30 degrees. Got it? So fine. Similarly, I need another current. What is another current? IY current. What is IY? Where is IY? Yes, IY is here. IYB minus IRY. See, where is IYB? IYB is here. Okay, what I need? Minus IRY I need. So I am just reversing this vector exactly opposite. By reversing that vector exactly opposite, then I got minus IRY. Okay, now construct a parallelogram. Okay, so by constructing a parallelogram, from this point draw a line parallel to this, and from this point draw a line parallel to this. Line should be parallel to this one, and this line should be parallel to that line. Okay, that is called parallelogram. So at some point both will meet. Now that point is what? Line current. Which line current? IY. Okay, so this current is IY. Okay, IY is nothing but line current. Understood? See, now I wrote. Now in order to find angle between IR and VRB, so I want to take reference is current. Now you need to write what is voltage drop in each and every phase winding. Now assume that if the winding is inductive, assuming if this entire load is inductive, delta connected load is inductive, means with respect to current, what about voltage? With respect to current, what voltage will happen in inductor? If the reference is voltage, current lags the voltage by 90 degree in inductor. Okay, for a pure inductor you apply some voltage. What is the current flows to that inductor? Lags the voltage by 90 degree. But if the reference is current, then voltage leads the current by how many degrees? 90 degrees. Okay, got it? So in the same way, with respect to this voltage, okay, with respect to this voltage, now which voltage I need? VRB I need VRB. So however, you can write all the voltages. Look at here, voltage in R phase. Okay, so this is VRY, voltage in that terminal, VRY, because in delta line voltage, phase voltage both are equal. Okay, so that going to lead the current by some pi degrees, so that is VRY. Next one is IYB. With respect to this, so the voltage, okay, that is VYB, lead the current by pi degrees, Similarly, with respect to this current, so that is very, very important, VBR. See, VBR leading this current by how many degrees? Pi degrees. See, don't think that voltage is in the top side, so voltage leads the current with respect to, that is correct. But don't think that so voltage is lagging. Okay, what is reference? What you are writing, that is important. Reference is current. With respect to current, assuming this is inductor, voltage leads by some pi degrees. If it is pure inductor, it leads by exactly 90 degree. Okay, I taken some practical inductive load, so therefore it lies between 0 to 90 degree. I don't know that angle, so I will write pi degrees. But I need to find angle between these two quantities, IR at an angle of VRB, similarly IY at an angle of VYB. See, I got here. So what is this? What is this line? IY. What is this? VYB. I can easily find angle between these two quantities. So what is this angle from here to here? What is this angle? 30 degrees. Okay, from here to here 30 degree, and from here to here pi degrees. So what is the overall angle from here to here? Very good, 30 plus pi. 30 plus pi is the angle between IY and VYB. Now I need angle between IR and VRB, but VRB is not there. We have VBR. I need VRB. So for that I will write one concept here. See, VRB can be written as minus VBR. VRB can be written as what? Minus VBR. Look at here. See, what is VRB? Voltage between points R and B, that you can write first one minus second one. VRB is VR minus VB. Now, coming to this side, minus within the bracket, what is VBR? VB minus VR. VBR is what? VB minus VR. Now simplify this. Then what happens? Minus VB, minus into minus is plus VR. Both are same, no? VR minus VB, VR minus VB. So therefore I can write VRB. VRB can be written as what? Minus VBR. Okay, VRB can be written as minus VBR. Otherwise VBR can be written as minus VRB. VBR can be written as minus VRB. Then what happens? Minus of, what is VRB? VR minus VB, and this will be plus. VBR is VB minus VR. Both the sides should be equal. So now what, look at here. Minus VR, minus into minus, plus VB. Got the clarity? VBR can be written as minus VRB. Okay. Minus VRB is VR minus VB, and VBR VB minus VR. Minus into VR minus VR, minus into minus plus VB. Let both the sides are equal. So therefore, look at here. Therefore, if I reverse this vector, VBR is there, no? VBR, if I reverse it, then it becomes negative. So therefore, I can write, I am reversing exactly opposite. Okay, exactly opposite. Okay. So therefore, this becomes minus VRB. That vector becomes how much? Minus VRB. Now, whatever the angle we have here, from this to this, okay, from this to this, same angle will be available here also. Same angle. So, what is that angle? This angle will be pi degrees. That angle becomes pi degrees. Now, this angle, okay, so from here to here, okay, from here to here, angle is 30 degree. So this is 30 degree, and that will be from here to here 30 degree. Now, look at the goal, IR and VRB. I need to find angle between IR and VRB. Where is IR? IR is here, okay, and VRB is here. I need to find angle between these two quantities. Okay, angle between this one and this one. How much you will get? See, from here to here, total is 30 degree. And this angle is pi degrees. What is this angle? 30 minus pi. Excellent. Very good, guys. So, very good. 30 minus pi. So, now I got all the angles. So, now I request all the subscribers, viewers and members, please pause the video and copy down this diagram neatly. Once it is completed, then later, okay, later you can watch it, what I am explaining after this diagram. That is much important. Okay, pause the video and then copy down. Okay. See, now I am going to erase this. All these notations now not required. I will erase this. Okay. Okay, guys. Now, once you got the phasor diagram completely wrote, now you put that angles, whatever the angle you got, put it in equation 3 and 4. Look at here. Now, W1 is equal to VL IL cos. What is the angle between IR and VRB? What is the angle between IR and VRB? Very good. 30 minus pi. Okay. That is what? W1 equation. Okay. And now W2 and W2 equation can be written as what? VL IL into cos. What is that angle between IY and VYB? See, IY is here, VYB is here. 30 plus pi. Very good. 30 plus pi. See, guys, without writing this phasor diagram, if you blindly wrote one is 30 minus pi, another one is 30 plus pi, means you are going to lose 3 marks. See, if this derivation is asked for 8 marks, for this diagram 2 marks will be there, and for this diagram 3 marks will be there. Okay, rest everything derivation 3 marks will be there. Okay, got it? So this diagram is very important. Okay. Worst case if you forget means there is no other choice. You can write directly. One is 30 minus pi, other will be 30 plus pi. See, this one in the phasor diagram is not required. Okay, is not required because VRY is not anywhere in this cost brackets. What is in the cost bracket? You need to concentrate on that only. Okay, got it? So now we all know that by adding 2 wattmeter readings, we should get three phase power. Okay, so W1 plus W2. Look at here, guys. Now power is equal to, what is W1? VL IL cos 30 minus pi plus, what is W2? VL IL cos 30 plus pi. Okay. Now you must apply cos A minus B and cos A plus B formula. That I will write here. Okay. So cos A minus B can be written as cos A cos B. Is it correct? I think it's correct. Cos A cos B plus sin A sin B. That is cos A minus B formula. Next is cos A plus B formula. Cos A plus B formula will be same thing. Cos A cos B, okay, minus sin A sin B. Okay, got it? Simply close your eyes and apply this formula, okay, to this equation. Simplify. You will get three phase power measurement. See, now that I am going to write it here. Okay, please pause it and write everything. Yeah, I hope this is very important. To reverse this vector, this concept is very important. Okay, guys, now I am applying this concept. See, now power is equal to VL IL within the bracket cos A minus B, cos A cos B. So A value is 30 degree, cos 30, B value is pi, cos A cos B, okay, plus sin A sin B, plus sin A sin B. So, and then plus, that is W1, okay. Next W2, VL IL within the bracket, again cos A cos B minus sin A sin B, minus sin A sin B. Got it? So now again easy simplified steps. So multiply this into this. So that color is not working. So I will write this one. Power is equal to VL IL, okay, into cos 30 cos pi, okay, plus VL into IL sin 30 sin pi. Okay, now plus into this, okay, you will get plus VL IL again cos 30 into cos pi, plus into minus minus VL IL sin 30 sin pi, VL IL sin 30 sin pi. Now see, plus VL IL sin 30 sin pi minus VL IL sin 30 sin pi, gone, cancelled. Now what is left? VL IL cos 30 cos pi, VL IL cos 30 cos pi. Both are same now. So therefore the next steps will be 2 times of VL IL into cos 30 into cos pi. So guys, what is cos 30 degree? Cos 30 degree is what? Very good. Root 3 by 2 into cos pi. Now 2 gone, cancelled. Okay. So final formula is power is equal to root 3 into VL IL into cos pi. So this is three phase power is measured. This is three phase active power formula. Okay. So got it, guys? Till here you should write for this question if they ask delta connected load. Understood, guys? Pause the video wherever it is required, okay, while copying, and then play it again. Okay, got it? Understood, guys? So what is three phase power formula? Root 3 VL IL cos pi. See, whether delta connected load or star connected load, three phase power formula is root 3 VL IL cos pi. In star connected also you will get W1 30 minus pi, W2 will get 30 plus pi. Only difference is phasor diagram for star connected is slightly different compared to delta connected phasor diagram. Got it? You must be practice both the methods, both star connected as well as delta connected load. Got it? Don't make choice. If they didn't ask any type of connection in exam, then you can write only star connected load. Okay guys? Okay, have a nice day. Take care. Meet your next lectures. Estimation of power factor based on wattmeter readings. That is the only topic left. After that topic, I will upload problems on three-phase AC circuits. I thought I was completed this, but I am not completed. That's why I want to do this. Okay. So next second lecture, problems will come. Okay. Next class, estimation of power factor based on wattmeter readings, and then all formulas comes under three-phase AC circuits. I will be listed. Then in the next class, I will upload problems. Okay. So tell your friends to subscribe to our channel. Okay. And then if they become member, see finally if you become a member to our channel, I will be helping how to answer Viva questions in basic electrical laboratory. I will be doing online class. Okay. And also I will do some revision classes for all the modules, and plus I will solve model question paper problems, okay, in online class. So these are all the benefits I can give to our channel members, okay, so they can perform well in the real-time exams. Okay guys, have a nice day, take care, meet you on next lecture, estimation of power factor based on wattmeter readings.